Students, today we are going to see the last topic of our chapter, adsorption and colloids, that is distinction between oil in water and water and oil, and afterwards we are going to see the application of emulsions. Okay, so let's start the distinction between oil in water and water and oil. See here, first is in oil in water. In oil in water, oil is the dispersed phase and the water is the dispersion medium. Correct? If oil in water is there, it means oil present in a smaller quantity and water present in a greater quantity. So oil is a dispersed phase and water is a dispersion medium in oil in water. And what about water in oil? In water in oil, water is a dispersed phase and oil is the dispersion medium. So water present in the lower quantity over here and oil present in the higher quantity. Understood, guys? Now the second point, oil in water. If water is added when the emulsion is formed by having a say oil in a smaller proportion and water in a greater proportion, and in that only if water is added, it will be a miscible with the emulsion. Understood? If water is added in oil in water, it will be a miscible in the emulsion. And second point, in water in oil, if oil is added, it will be miscible with the emulsion. Understood, guys? If water is a solvent or water is a dispersion medium, and in that case only water is added, then it will be miscible. So oil in water, water is miscible. And what about water in oil? Oil is miscible. Understood? This is the second point. Now go for the third one. The third, for oil in water, an addition of small amount of electrolyte make the emulsion conducting. Okay, if you are having an emulsion of oil in water, okay, and in that only if you add small amount of electrolyte contains the positive and the negative charge species, correct? So if you add small amount of electrolyte in the emulsion of oil in water, that emulsion start conducting the electricity. Understood? On the other hand, if you are going to add small quantity of electrolyte in emulsion of water in oil, it has no effect on conductivity. Understood, guys? So in oil in water, by the addition of small amount of electrolyte, it shows conductivity, but emulsion of water in oil, by adding a small quantity of electrolyte, has no conductivity. Fourth point, for oil in water, water is continuous phase. Okay, water being a dispersion medium, so it is a continuous phase. And what about water in oil? Oil is a discontinuous phase because oil is a dispersion medium over here. And the last one, that is the fifth point, in oil in water, first of all, basic metal sulfates, okay, metal sulfate like barium sulfate, calcium sulfate, copper sulfate, then water soluble alkali metal soap are as emulsion over here. So these are the example given over here. So example of a oil in water, basic metal sulfates, then water soluble alkali metal soap are some examples. Here for water in oil, fifth one, water soluble soap such made up of zinc, aluminium, Fe, then alkaline earth metal are used as a emulsifier over here. So these are the example over here. Understood, guys? So simple 5 points are there of point of difference between oil in water and water in oil. Please prepare it very well. Now the next one is the properties of emulsion. There are few property, only 4 properties are there of emulsion. We'll see one by one properties of emulsion. See here, first one is the emulsion can be diluted with any amount of dispersion medium. If you are having an emulsion, correct, either water in oil or oil in water, so that emulsion can be diluted with any amount of a dispersion medium. यानी आप कितना भी amount of dispersion medium है यानी solvent add कर सकते हो. On the other hand, the dispersion liquid when mixed form a separate layer. Okay. Second one is the droplet in the emulsion are often negatively charged and can be precipitated by electrolytes. Generally in the emulsion, the droplets जो होते हैं that are generally negatively charged species. Understood? Most of the time are negatively charged species, and that can be precipitated by adding the electrolyte. If any electrolyte can be, if we add, then that the precipitation or a coagulation of that negatively charged droplets will be there. Understood? The third point is emulsion shows Brownian moment as well as Tyndall effect. Okay, Brownian moment यानी the moment, zigzag movement of the particle. Understood? So here the emulsion being a colloidal particle only, or being a one of the type of a colloidal solution or colloidal dispersion, so it do shows the Brownian moment. Brownian moment means the moment of a colloidal particle in a zigzag manner. And what about the Tyndall effect? If you pass the light into the colloidal dispersion, then you can easily observe the beam of a light through that colloidal dispersion because of the scattering of light, and you can see the cone of the light in that case. On the other hand, if you are having a true solution, so it won't be possible. Okay, the beam of light is not visible to us. Understood na? That is called Tyndall effect. So here emulsion being a colloidal dispersion shows the both the effect, that is Tyndall effect as well as Brownian moment. And the last property of the emulsion is the two liquid in emulsion can be separated by heating, freezing or centrifuging. Okay, the two immiscible liquid when mixed together, it forms the emulsion, no doubt about that. Oil in water, water in oil, you can add say petrol in water. You may take chloroform and water. Understood? Chloroform, water, both are immiscible with each other, and that's why they used to form the emulsion. So these emulsions can be easily separated by heating. Either you heat, so the low boiling point liquid gets evaporated easily first of all, and then you can collect that vapor of that liquid and then condense back to get the proper liquid. That is one method, heating say. Second one is freezing. So those liquid which do have a lesser freezing point or a low freezing point freeze, and the other one liquid remains as it is in the liquid form. So by freezing only we can separate, or by centrifuging. See, centrifugation means separation of say the two things or two particles or a two layer by using centrifuge machine. Guys, centrifuge machine is new for you actually. एक होल्डर रहता है through which on that only the test tubes are kept, and test tubes में रखा जाता है particles जो या फिर solution जिसको separate करना होता है, और उसको फिर rotate किया जाता है. So by the rotation only the separation is done. Understood? So centrifuge machine generally lab में भी नहीं use करते 11th-12th के लिए. हाँ, centrifuge एक apparatus होता है छोटा सा जो कि practical में use करेंगे. So you may get an idea of a centrifuge manual apparatus when you will perform the practical, especially the salt analysis practical in 11th as well as in 12th standard. So जब college start होगा तो I think आपको इसकी idea आ जाएगी. So the two liquid in emulsion separated by heating or freezing or centrifuging. Understood, guys? So these are the properties of the emulsion. The last one is the application of colloids. Okay, so the colloidal dispersion or colloidal particle shows application in different field. The first one is electrical precipitation of smoke. Okay, what is smoke? Smoke is a colloidal solution of a solid particle of carbon, arsenic compound, arsenic oxide, arsenic sulfide, dust, etc. in the air. Correct, no? So when smoke is allowed to pass through the chamber containing plates having charged smoke particle, they lose their charge and gets precipitated. If the smoke is there and that smoke is passed through the chamber containing the plates having charged, then the smoke particles lose their charges. Understood? Because of that opposite charge species, they attracted towards the different plates or the different opposite electrodes, and then after neutralization will take place, and that's why the smoke particle lose their charge and gets precipitated. So the smoke particle can be precipitated. So that is one, electrical precipitation of smoke. That is one application. Second one, purification of a drinking water. See, in case of a drinking water, generally water we obtain from the natural sources do contain certain colloidal impurities. Understood? Colloidal impurities रहेंगी, बहुत सारे उसमें minerals होंगे, salts होंगे. Understood? By the addition of alum यानी फिट करके कहते हैं ना हम लोग, the formula is K2SO4 Al2SO4 thrice 24H2. I repeat, K2SO4 Al2SO4 3 times 24H2. That is the formula of alum. Okay, so in that water if we add alum, then the colloidal impurities gets coagulated, yani precipitated, and get settled down. Understood? This makes water potable as well. So here, purification of drinking water. is can be done by the coagulating of a colloidal particles present in the water only by addition of a alum. That is one more application. Next one is in the medicine. See, in the medicine, generally medicines are colloidal in nature. Most of medicines are colloidal in nature, in fact. How? See, colloidal medicines are more effective owing to large surface area, to the volume ratio of a colloidal particle, and easy assimilation. Understood? Generally these medicines based on colloidal nature, where they provide the large surface area, and as the surface area is more, the volume will be more, and more effective medicine will be work over there. So that is the application in medicine of a colloidal particle. Next is in the rubber industry. See guys, rubber is actually two types of rubber we are getting. One is synthetic rubber and another one is artificial natural rubber. Synthetic is definitely the purely prepared in industry with the help of chemicals only, and this one natural rubber is actually getting from the rubber tree. The rubber tree gives the latex यानी जो sticky material होता है, that rubber tree से मिलता है, correct no? सो उसको ट्रीटमेंट करके फिर टेंसाइल स्ट्रेंथ और उसकी थर्मल स्टेबिलिटी इंक्रीज करके फिर वो उसको हम लोग रेगुलर यूज़ में लेके आते हैं. सो इन द रबर इंडस्ट्री, द रबर इज ऑब्टेन बाय कोएगुलेटिंग ऑफ लैटेक्स. अंडरस्टूड? जो लैटेक्स है, लैटेक्स यानी द थिंग्स विच कमिंग आउट फ्रॉम द रबर ट्री ओनली, सो उसको लैटेक्स कहते हैं. सो लैटेक्स को ट्रीटमेंट करके फिर उसका प्रेसिपिटेट बनाया जाता है, यानी मोर एनहांस क्वालिटी रबर बनाई जाएगी, जहाँ पे उसकी थर्मल स्टेबिलिटी ज़्यादा होगी, हायर टेम्परेचर पे भी वो मेल्ट नहीं होगा, उसकी टेंसाइल स्ट्रेंथ ज़्यादा होगी, यानी वो जल्दी टूटेगा भी नहीं. अंडरस्टूड? इलास्टिसिटी विल बी इंक्रीजेज. सो द मोर क्वालिटी ऑफ अ रबर is prepared by using coagulation or precipitation of a latex only. Next one is cleansing action of a soap and detergent. See, soap and detergent forms the micelle, and that actually forms the colloidal suspension over there, or colloidal dispersion over there. So that is also here the cleansing action of a soap and detergent works on the basis of a colloidal dispersion. And the next one is photographic plates, film, industrial products like paint, ink, synthetic plastic, rubber, graphite lubricants, cements. These all are the colloidal particle actually. सीमेंट है, ये कोलाइड्स है, रबर है, कोलाइड्स है, ग्राफाइट लुब्रिकेंट्स ऑल्सो कोलाइड्स, सिंथेटिक प्लास्टिक्स, इंक, पेंट, एवरीथिंग आर एक्चुअली कोलाइडल डिस्पर्सन. अंडरस्टूड गाइज? सो everywhere we are getting we cannot imagine the life without the colloidal dispersion over here. Understood guys? क्योंकि ये डे टू डे लाइफ में रबर यूज़ होगा, सिंथेटिक प्लास्टिक यूज़ होगा, हमारे यहाँ पे पेंट, इंक हम लोग यूज़ करते हैं लिखने के लिए, सो एवरीथिंग दिस ऑल थिंग्स विल यूज़ रेगुलरली. इवन सोप डिटर्जेंट हम लोग रेगुलरली यूज़ करते हैं, एवरी डे यूज़ करते हैं एक्चुअली. अंडरस्टूड गाइज? सो दीज आर द एप्लीकेशंस ऑफ दिस वन कोलाइडल सोल्यूशन. सो गाइज, पूरे चैप्टर में एडजॉर्प्शन एंड कोलाइड्स में हमने पढ़ा फर्स्ट ऑफ ऑल एडजॉर्प्शन, एब्जॉर्प्शन, डिफरेंट टर्म्स लाइक सॉर्प्शन, डिसॉर्प्शन, देन द टाइप्स ऑफ एडजॉर्प्शन, फिजिसॉर्प्शन, केमिसॉर्प्शन. उसके बाद फिर हमने एप्लीकेशंस ऑफ एडजॉर्प्शन पढ़ा, नंबर ऑफ एप्लीकेशंस आर देयर. उसके बाद फिर हम लोग चले गए थे कैटालिसिस के ऊपर, कैटालिसिस यानी क्या, देन टाइप्स ऑफ कैटालिसिस. अंडरस्टूड? उसके बाद फिर हम लोग चले गए ऑन दी कोलाइड्स. ठीक है, कोलाइड्स लंबा टॉपिक था जहाँ पे हमने उसके प्रॉपर्टीज़ पढ़े, प्यूरिफिकेशन ऑफ कोलाइड्स पढ़ा, उसमें प्रॉपर्टीज़, प्रिपरेशन मेथड ऑफ कोलाइड्स हमने पढ़ा. ठीक है, उसके बाद फिर हम लोग आए यहाँ पे इमल्शन के ऊपर, इमल्शन, टाइप्स ऑफ इमल्शन, फाइनली अप टू द एप्लीकेशन ऑफ इमल्शन. सो गाइज, अच्छा ईजी चैप्टर है, थियोरेटिकल चैप्टर है प्योरली. सो आप जितना एक या दो बार आई थिंक कॉन्सेंट्रेटली लर्न कर ले उसको, सो तो पूरे आराम से याद हो जाएगा ये चैप्टर. सो प्लीज़ डू इट वेल. थैंक यू.